All right, so we're going to do the last section of soil science, which is going to be soil fertility. A couple of review terms here, review conditions as far as deficiencies go, and then we'll move into closing out the unit here in a few days. So a couple of terms and definitions. Number one is essential nutrients, and we've already kind of talked about it, and we've hit on some essential nutrients before, but these are elements that are necessary for plant growth and reproduction. Some examples of these are nitrogen, phosphorus, and potassium. Plant or nutrient deficiency, or really deficiency of anything, is when plant condition where an essential nutrient is not sufficiently available. A symptom, and just like with humans, when you're sick, visual sign or condition that can result from a deficiency. Symptoms aid in a diagnosis or aid in diagnosing a deficiency. So if we understand what we're seeing or we understand the symptoms, then we may be able to understand what exactly is lacking or too much of, and we could change it without having to do an expensive test. A few more terms. Fertilizer. Okay, so fertilizers can be natural, they can be manufactured, or they can be processed material or mixture of materials that contains one or more of the essential nutrients. These are available in dry form, liquid form, and as a gas. All right, so fertilizer terms. So you have analysis. All right, so an analysis is going to be the percentage of water-soluble content of nitrogen, phosphorus that's expressed in P2O5, and potassium that's expressed as K2O in the fertilizer. The brand is going to be the trademark of the company which to produce the fertilizer that is being used. And a complete fertilizer is a fertilizer which supplies all three of the primary nutrients plants need, which are nitrogen, phosphorus, and potassium. All right, so chemical elements essential for plant growth. So you have non-mineral and mineral nutrients that are needed. The non-mineral ones typically come from air and water, and this is carbon, hydrogen, oxygen, and nitrogen. And your minerals ones come from the soil. Your primary, of course, is going to be nitrogen, phosphorus, and potassium. And then you can see secondary calcium, magnesium, and sulfur. And then you have your micronutrients down in there as well, which we've talked about all those already as also. 10 essential elements for plants. Okay, you can see them there. I'm not going to read through them. A simple little saying, in case you're one of those that likes to make an acronym, so to speak, to remember. C. Hopkins Cafe is mighty good. You can come up with anything you want to help you remember the 10 essential elements for plant growth. So with growing anything, whether it's for, and specifically if it's for profit, if any of these are off, okay, profit is going to be affected. And we would think about the main nutrients, of course, that nitrogen, phosphorus, and potassium. Of course, you would say that, but also look that even though they're main, everything else kind of builds on the base for the main nutrients and the product. Okay, these micronutrients are just as important to be right. I mean, they have to be dialed in, so to speak, as your potassium, phosphorus, and your nitrogen. If you only focus on potassium, phosphorus, or nitrogen, you're not going to reach maximum yield or the maximum potential for that crop or whatever it is you're growing. So all of this works together. All right, so some functions. So carbon, hydrogen, and oxygen are needed in the plant process called photosynthesis and cellular respiration. And by this point in your high school career, you have talked about photosynthesis and cellular respiration quite extensively. Approximately 95% of the weight of plants come from the products of photosynthesis. So if you don't remember what the products of photosynthesis are, I would suggest you going back and reviewing that. Primary nutrient function, so nitrogen. So it gives the color green to the plant. It induces vigorous, rapid growth in plants. It increases protein yield, aids and promotes seed and fruit development. Nitrogen makes up around 80% of our atmosphere, and yet it is one of the most critical elements for plant growth. Plants cannot use nitrogen as a gas. It must be combined with other elements, which is known as nitrogen fixation. So the nitrogen that is found, and this is also a review, the nitrogen that is found as gas in our atmosphere cannot be used by living things. It has to be fixed. And remember what the term fixation means is you're taking an inorganic molecule and making it organic. That's what's happened with nitrogen. So in order for nitrogen to be used by plants, it has to be fixed. Phosphorus. So it's important to germinating seedlings. It contributes to early maturing crops, and it is necessary for seed and fruit formation, and it stimulates root growth. Potassium is necessary for the production and translocation of carbohydrates. It produces plumper seeds or more full seeds, controls water intake and respiration, and stiffens straw and stalks. Okay, so it gives it that structure. Some secondary nutrient functions. Sulfur is necessary for nodule forming in legumes. It's associated with plant enzyme systems, stimulates seeds production. It affects um, it affects protein and crop quality. Calcium speeds the decay of organic matter, stimulates formations of nitrates, promotes root and leaf growth, and is necessary for nodulation of legumes. So magnesium is necessary for chlorophyll and green plant color. It increases absorption of phosphorus, aids in the formation of fats and oils, and it is important in plant enzyme systems. All right, so some symptoms of nutrient deficiencies, and this is going to be reviewed, but we want to hit on a couple of the big ones. Remember, a deficiency is a condition where something is missing or not enough of it, or maybe sometimes too much, or well, not deficiency. But some negative consequences could be caused from having too much nutrients, but that wouldn't fall in the word or in the vocab term of deficiency. Symptom is a visual sign, and we can see changes in color, changes in structure, changes in appearance. Will let us know that something's going on. All right, so if nitrogen is deficient, if you have a nitrogen deficiency, so the growth is going to be stunted, which means it's not going to happen as fast. You're going to get a yellowish green or yellow or light green color in the foliage or leaves area. Older leaves affected first, starting at the tip and moves along towards the middle of the leaf. Okay, so nitrogen deficiency in corn, small ears and low protein content result from nitrogen deficiency. You will see a lot of wasted spot on an ear of corn, and this picture can't show, but you'll also see a yellow color in the leaves of the corn plant. So with phosphorus deficiency, you're also going to have stunted growth, very dark green color in the leaves, purple leaves or portions of leaves in advanced stages, and older leaves are going to be affected first. So phosphorus controls stalk size in corn. Okay, phosphorus is needed when ears are small and twisted and kernels are undeveloped. And phosphorus shortage during early weeks causes a shallow root system. Potassium deficiency. Shorter plants, bronzing or browning of leaf color, lodging or the bending of stems occur. Leaves show yellow to brown coloring along leaf margins, followed by complete browning. Sulfur. So young plants have stunted appearance. Leaves have a light green to yellow coloring. Stems are thin and spindly. Sulfur deficiency symptoms are similar to in the appearance of nitrogen deficiency symptoms. Magnesium. The leaf parts between veins show a whitish color. Leaf tissues become yellow. Veins remain green. Leaves curl upward along the margins. Other conditions besides deficiencies may cause abnormal plant growth. You can have cold, too wet, too cold, too wet, lack of sunlight, maybe some disease have set in, insect damage, which is always a problem, or improperly applied chemicals are some examples. Last slide is factors that influence fertilizer use. Physical and chemical conditions of the soil. This is where a soil test comes in play. We know what the soil is lacking or our nutrient content in the soil. We know what to, it helps us develop a plan, what we're going to add to it, what it needs, what it doesn't need. Maybe the crop to be grown needs a little bit more of one of the nutrients or micronutrients than the others. So maybe that is going to play a role into which fertilizer is used. Climate, and what's the climate looking like? What's it typically like? What's the average climate in the area? And then, of course, time. All right, so be sure you complete the video form that goes with this, and if you have questions, let me know. Thank you.